So welcome to God Academy. Myself, Ranti Kumar, a physics professor. So today I am going to discuss about acceleration due to gravity, right? So first of all, what is this? Nothing but if a body has been falling freely from some height of a building, so what we say is that initial its velocity is 0. So when it is coming down, we can observe that its speed is increasing. Nothing but velocity is increasing, thereby acceleration is also increasing. Okay. So here we observe that the body is moving towards the center of the earth with an uniform acceleration. So here we can observe one more point is that there is some attraction force because of earth, due to which the body is coming towards its center. Okay. So now let me define what is acceleration due to gravity. It is nothing but an uniform acceleration. What do you mean by uniform? Uniform nothing but constant. Its value is not changing. Okay. Uniform is nothing but constant. Its value is not changing. So the uniform acceleration of a freely falling body, in the sense it is passing towards the center of the earth just because of gravitational force of attraction. So now this is defined as the acceleration due to gravity. Understood? So let me write it. The uniform acceleration of a freely falling body towards the center of earth, towards the center of earth, due to earth's gravitational force of attraction, due to earth's gravitational force of attraction, is called as acceleration due to gravity. Okay. So here this acceleration due to gravity is denoted by symbol small g, and its value is constant at any given place for all bodies. In the sense, it is independent. Independent sense, it is not depending. It is not depending upon the size, shape, nature and material of the body. So whatever the body may be, it is not depending. Its value is constant at any given place. Stressing here, at any given place. The body may change, or its nature may change, or the type of material may change. Its value is not changing. It is constant at a given place. I am saying at a given place. It means at a particular location. Okay, on the surface of earth. Suppose if I am changing the place from one point to other point, let me say that at the equator of earth or at poles of earth, the acceleration due to gravity is maximum at poles of earth, which is equal to 9.83 meters per second square, whereas its value is minimum at poles of earth. Okay. So repeating, my dear children, the acceleration due to gravity is maximum at poles of earth, that is 9.83 meters per second square, whereas its value is minimum at the equator of earth, that is 9.78 meters per second square. Is it clear? So repeating, my dear children, so here this acceleration is nothing but uniform acceleration of a freely falling body. So if a body is just dropped like this, it falls freely. In the sense, its initial velocity is 0. Now when it is moving down, we can observe its velocity as well as acceleration is increasing. So here we can say that it is moving towards the earth just because there is some attraction force. Gravitational force is there which is attracting the body. That is the reason why it is moving towards the earth, or you can say towards the center of the earth. So that kind of acceleration is called as acceleration due to gravity. And once again I am telling you, it is constant at any given place. Repeating, constant at any given place. So what does it mean? If the place changes, no doubt its value is changing. Okay. So at poles and at equator of Earth, so two cases are there. So the value of G is maximum at poles of Earth, which is equal to 9.83, whereas at equator its value is minimum, which is equal to 9.78 meters per second square. So once again I am telling you, the value of G in the sense acceleration due to gravity, small g, is independent of size, shape, nature as well as material of the given body. It depends only upon the place. Only upon the place. Okay? Whether it is at equator or at poles. On the Earth, I have given you two different values. That is, one is 9.83, that is at poles. Another one is 9.78, that is at equator. Whereas if I am interested to know the value of G on the surface of the moon, then what I have to say? Exactly on the surface of the moon, it is 1/6 of its value on the surface of Earth. 1/6 of its value on the surface of Earth. Okay, let me write those points. This acceleration due to gravity symbol, it is denoted by small g. So this is the symbol of acceleration due to gravity. Next, it is independent. What does independent means? Not depending. It is independent, okay, of size, shape, nature and material of the body that you have taken. Okay. Its value is constant at a given place. So try to understand this. I am saying at a given place means the place is not changed. Okay. Its value is constant at a given place for any body. It means that if the place is constant, automatically this value is constant. If I am changing the place, then what happens? Okay, constant at any given place for any body. Next one, its value changes from place to place. So here I have to tell you clearly, place to place I am saying its value is changing. So what are the places we are having on the surface of Earth? Okay, what are the types of places? So we are having two cases here. One is at poles and other one is at equator. So the value of G at poles is equal to 9.83 meters per second square, whereas at equator the value of G is equal to 9.78 meters per second square. Understood? In these two cases, we could observe that at poles it is maximum. So G is maximum at poles and minimum at equator. Understood, my dear? Okay. Now, what is the, if you are interested to know the value of this acceleration due to gravity, now I am changing the surface. Instead of Earth, I am saying moon. So what is its value on the moon? So I told you exactly 1/6 of its value on the surface of Earth. That is, acceleration due to gravity on moon is equal to 1/6 of its value on acceleration due to gravity on surface of Earth. Okay, is it clear? So since we are having two different values of G on Earth, so its value changes from place to place. This is on Earth, okay? On Earth. Since we are having two different values of G on Earth, so while solving numericals, we used to take approximately the value of G on Earth is equal to 9.8 meters per second square. Approximately, you should take this. So now here he is saying that the value of G on the moon, that is acceleration due to gravity on the moon, is 1/6 of its value on the Earth. That is 1/6 into 9.83. Like this we used to say. Okay? Meters per second square. Is it clear, my dear children? So now we can look at this carefully. Okay? Note down this. You will understand. So based upon this, we are going for the next topic, that is motion under gravity. If you know what is acceleration due to gravity, then we can understand what is motion under gravity. So in this, we are going to study again 3 different cases. Okay, for a freely falling body, as well as for a body projected vertically upwards and a body projected vertically downwards. Is it clear, my dear children? Okay, have a note of this. So next one is motion under gravity or motion due to gravity, no problem. Motion under gravity, okay, or motion due to gravity. In this, we are going to study 3 different cases. That is, equations of motion for a freely falling body. For a freely falling body. Right? So now there is a body like this. So let this circle assume it as a body. Okay. So I am saying freely falling. What do you mean by falling? So this is what do you mean by freely falling? If I say this is a body, if I just leave like this. Okay. Now this comes under freely falling case. So freely falling in the sense, let me represent it by dotted lines, whose initial velocity is 0. Repeating, initial velocity of a freely falling body is 0. Because if you observe, I'm just leaving it like this, dropping, means I'm not applying any kind of velocity initially. So initial velocity is given by the symbol u. So initial velocity of a freely falling body is 0. Now, as it is falling towards the center of the earth, since I am leaving it, it is falling towards the earth. Okay, as I told you, when it is moving towards the center of earth, it was given by the name acceleration due to gravity, that is small g. Okay, so as it is falling freely towards the center of the earth, then let me assume that its acceleration due to gravity is nothing but g. Okay, so only these 2 cases we know. Next, falling towards the center of the earth and hitting on the surface of the earth like this. Okay. So at this point, let us assume that the velocity is v. So here u stands for initial velocity. Since it is freely falling, or the other way of saying is that dropped. Body has been dropped. Or other way of saying is that released. Okay. So like this, I will be using 3 different terms. So here I am not applying any kind of velocity initially, simply I am leaving it. Okay. So its initial velocity is 0. So when it is coming towards the center of the earth, I have to say that its acceleration is equal to small g, nothing but acceleration due to gravity. When it hits the earth, we used to say that there is some velocity. Okay. So let us find its velocity after a time t and after traveling some distance h, what it may be. Those things we are going to see in detail later on. Okay. Now, what are its equations? Okay. Before looking at this one carefully, we have to Before looking at this carefully, we have to know few more parameters. Like just now we saw initial velocity, final velocity, acceleration due to gravity, and let us assume the time is small t, and let us assume the distance traveled is h. Better, no? So instead of saying yes, it's better to say h. So from here to here, let the distance traveled s is given by symbol h. S is nothing but h, height of the building. Okay. So this is a building or a tower, whatever it may be. So from here, a body has been released or dropped. Let's drop like this. So initial velocity is equal to 0. I stands for initial, or simply you can say u. Why should I get confused? Initial velocity. After traveling to certain distance, it means that let us assume the height of the building as h. Assume the height of the building as h, which is nothing but distance traveled s. Okay. So when it reaches the foot of this tower or foot of this building, here there is a velocity, that is v. We don't know that. You have to calculate that. So if h is given, how to find out velocity? Height of the building is given, how to find out the velocity? Suppose if I say that after t seconds it is coming down. So if time is given, then how to find out the velocity? These cases we are going to see, right? Now, previously I told you the 4 equations. Equations of motion. We have discussed earlier. In that, the first one is v is equal to u plus at. Second one, s is equal to ut plus half at square. And third one, v square minus u square is equal to 2as. Fourth one, distance travelled in n second is equal to u plus a by 2 into 2n minus 1. Like this we have discussed earlier. These are the equations of motion. Now, how these equations are applicable for a freely falling body? So I am telling you about here, if it is a freely falling body, you have to say initial velocity is 0. Since it is coming downwards, its acceleration due to gravity, or you can say acceleration is nothing but acceleration due to gravity, because there is a Earth's effect. Okay. So while coming downwards, the Earth is pushing it towards its center, pulling it towards its center. So I'll take it as positive. Okay. So here this is plus g. Acceleration equal to plus g. See the way I use it. Equations of freely falling body. So assume initial velocity is 0, okay, which we know, and acceleration, since it is coming downwards, it is plus g. So this downward arrow will tell you that it is coming downwards as Earth is expecting to come down. So we can say that the body is a friend of the Earth. If it is friend, you take it as positive, like that you assume. Okay. So from there, the equation 1 can be written as v is equal to, since u is 0, 0 plus, just observe these 2 equations, my dear. So in place of v, in place of u, I have written 0, in place of a into t, a is given by g, and in place of time, t. I have to write t only, no change in that. Now coming to second equation, s is the distance. As I told you, the distance is nothing but height of the tower. So h is equal to, in place of s, I am taking h. Okay. ut, you are told earlier 0 into t plus half a t square. So half is okay. In place of acceleration, that is plus g, and time is t square. Like this I will get. Now coming to the third, as I told you, v square minus u square, where u equal to 0. So v square minus 0 is equal to 2, whereas acceleration, that is plus g, and distance s, nothing but height of the tower or height of the building. Okay. Now coming to the fourth equation, distance travelled in nth second, so that is s nth is equal to u, in place of u 0, in place of acceleration g, by 2 into 2n minus 1. This is the way I could write. Okay, my dear. So let us write once again. Just look what is there here. V equal to 0 plus gt. So what I can do here is that little bit I can. Okay. Right. V equal to 0 plus gt means only gt. So V equal to gt. This is what is equation number 1. And h is equal to 0 into t, that is 0. So remaining part is half gt square. Next case, v square minus 0. So just it is only v square is equal to 2gh. And here nth, distance travelled in nth second. So 0 plus g by 2 is also 0. So it is j by 2 into 2n minus 1. So like this, we'll get 4 equations. These are the 4 equations which describes us the motion of a freely falling body. Okay? Okay, my dear children, I hope you understood this. So these are the 4 important equations which describe the motion of a freely falling body. Right? So based upon this, we will be solving few numericals. You will understand better in depth. So next, let us see its applications one by one. For a freely falling body, means what are we going to study now, we are going to apply. For a freely falling body, what is the ratio of, for a freely falling body, we have to find out the ratio of distance covered by a body for 1 second, 2 seconds, 3 seconds, 4 seconds, etc. So, for its journey from top of the tower to foot of the tower, okay. So, for the first 1 second, how much it is covering? Then, for the first 2 seconds, then for the first 3 seconds, and later on 4 seconds, and later on for n seconds. You have to find out what is the ratio, distances covered for 1 second, 2 seconds, 3 seconds, 4 seconds, etc. And then finally, the ratio. If you know the ratio, you could solve sums very easily. Okay. For a freely falling body, the ratio of distances or distance travelled by a body in a time interval of 1 second, 2 seconds, 3 seconds, 4 seconds, and so on like this. Okay. So how we calculate this? See, look, my dear children, here I am saying seconds. Seconds. It means seconds. Means from the beginning of journey, we have to find out. Understand what English terminology. Seconds I am saying from the beginning to some point 1 second. Again from the beginning to other point 2 seconds. Again from the beginning to some other point 3 seconds. It means I am trying to find out the overall distances travelled from top of a tower or top of a building to some points in a given interval of 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds and so on. But not for the particular second. That is different one. That is next case. We will go to study. Okay. So this is a tower or building, whatever it may be. Whatever you like, just write down. Okay. Tower or building. Building or a tower. So, let me say the height of the building is something like h. At this point, point A, top of the building, now a body has been released or dropped or freely falling. So, as I told you earlier, freely falling is nothing but freely falling is nothing but we could also say dropped, or we could also say released, where its initial velocity is 0. So a body has been dropped. Okay, so this is a body has been dropped. So its initial velocity at this point is 0. So at this point is 0. Since it is falling downwards, the acceleration is nothing but plus g. As I told you earlier, while coming downwards, it is plus g. Okay, then you may be having some other doubt. While going up, what happens? Just reverse, minus g. Okay, we are going to study those cases later. Now, what is the formula to find out the distance? As I told you earlier, s is equal to ut plus half a t square, right? So, for 1 second, the time is taken as 1 second at t equal to 1 second, like this. So, what is s? As I told you, this u for a freely falling body is equal to 0. So, this part is 0. So, 0 plus half g t square. So, directly could write s is equal to half g t square. Just what I told you. This is only for a freely falling body. Okay. So, s is equal to half g. You told me here 1 second. So, I will write only 1 square. Now, at time t is equal to 2 seconds. Okay. So, s is equal, let this be s1, now s2. Half g. Now, time. In place of this t, I could write 2 square. Now, at t equal to 3 seconds, right? So, s3 is equal to half g t square. Now, the time is 3. So, it is 3 square. Similarly, at t equal to 4 seconds. So, s4 is equal to half g 4 square. Like this, I will continue. At some time t equal to n second. So, distance for n second, half g n seconds. It is half g n square. Like this I will get. Okay, my dear children. Now, I have to take the ratio of all these things. This is what is my interest. So, what I could do here, g into 1 square is g by 2. This is g by 2 into 2 square. Let me write like this. This is g by 2 into 1 square. Okay. This is g by 2 into 3 square. This is g by 2 into 4 square. Whereas this is g by 2 into n square. Like this I will write. If I am interested to take the ratio of all those things, I could cancel out all the common value. That is g by 2. So, here there is g by 2, here there is g by 2, and here there is g by 2, and here there is g by 2, and here there is g by 2. So, all are common. So, when I am taking ratio, this common must be, okay, erased, or you can say cancelled. So, that is S1 is to S2 is to S3 is to S4, like this, okay, is equal to g by 2 into 1 square is to g by 2 into 2 square is to g by 2 into 3 square is to g by 2 into 4 square. Like this I can write. Since in every case we could observe that g by 2 is common, I could cancel this. So, now the final answer is 1 square is to 2 square is to 3 square is to 4 square. Like this I am getting. So, if anybody asks you, find out the ratio of a freely falling body for a given time interval of 1 second, 2 seconds, 3 seconds, 4 seconds, like that. So, if it is 1 second, you have to say 1 square. If it is 2 seconds, you have to say 2 square. For 3 seconds, say it as 3 square. For 4 seconds, say it as 4 square. Like that you could say. For n seconds, not nth second. I am not saying nth. I am just saying n seconds. Find out the difference between what I am saying. Okay. Just observe my frequency. It is not n. It is not nth second. It is only n second. N seconds. Okay. So, if it is n seconds, then you have to get it as n square. As I told you here, it is n square. Okay. So, nth, that is different concept. We are going to study after this one, right? So, like this, if I go, I will get 1 square is to 2 square is to 3 square is to 4 square. Now, what will be the answer? And so on, if I could write 1 is to 4 is to 9 is to 16 is to so on, like this. So, this is what the ratio of the distance covered for 1 second, 2 seconds, 3 seconds, 4 seconds, so on. Okay, my dear children. So, S1 is to S2 is to S3 is to S4 is to so on. So, I hope it is clear. If you have any kind of doubt, okay, you just go back and look at each and every point, whatever I am discussing with you. So no doubt that you will understand better. Okay. Okay. So now, okay, as I told you earlier, the next topic, nothing but similar to this. Previously, we are finding the ratio of the distances traveled in the given time interval of 1 second, 2 seconds, 3 seconds from the beginning onwards, right? So now what I do is that, again from the beginning only, there is no change, but I will find out the ratio of distances for every successive interval of time. What do you mean by that? Successive interval of time. What do you mean by that? Suppose journey is carried for 10 seconds. Okay. Then my interest upon is that I have to find out the ratio of distances for first second to second second to third second to fourth second, like that, to each and every second. I would like to find out the distance covered, and finally the ratio of all those distance in each and every second. That is what is my interest. Okay. So now let us do that. Find the ratio of distance covered in successive intervals of time. Okay. For a freely falling body. This is what is important. Freely falling body. As I told you earlier, the formula for distance in case of freely falling body is half gt square. Clear? But now I am interested to find out only for successive intervals of time. What do you mean by successive intervals? Successive intervals in the sense each and every second at that particular instant, right? So let me write here. Successive intervals means each and every second. Each and every second. If this is the case, I should not use this formula, because S is equal to half gt square tells you from the beginning to overall journey the distance traveled. But here we are cutting it. The full distance has been cut into 10 pieces because 10 seconds, no? So 10th second we want, 9th second we want, 8th second we want. Like this we are cutting into 10 pieces. So for each and every second I want to find out its distance. So in such case, this formula is invalid. So this formula is invalid. Then what I have to do? I have to go for the distance traveled in each and every second. And nothing but S nth is equal to u plus a by 2 into 2n minus 1. This is what the general formula I told you. But for freely falling, we have done small adjustments, no? I told you that u equal to 0 and small a equal to g. So now, with the adjustments, if I continue for a freely falling body, I will write this one as distance on n second is equal to g by 2 into 2n minus 1. So this is for freely falling body. For freely falling body. Okay. Now let us use this. Again, I will take the tower or a building like this of height h. You can say distance or a height h. So let us name this point as u. From here a body has been dropped. So that is the reason I am putting here dotted lines. Since it is dropped, okay, dropped or freely falling, both are same. Its initial velocity is 0. Here the point is a. So velocity at point a equal to 0. Since it is coming downwards, acceleration is equal to g. Okay, so all these are similar, same case as before. Now we have to use this formula. Now at t equal to 1 second initially. So what is the formula? S nth is equal to g by 2 into 2n minus 1. So if it is 1 second, that is first second, g by 2 into 2 into 1 minus 1. So 2 minus 1, 1. So the answer is 1 g by 2. Suppose if t is 2 second, better to say second, okay, at second. So you better write this one as at first second. First in the sense like this, first second. Okay, second. What is the formula again? G by 2 into 2 times of 2 minus 1. So 2 2s are 4 minus 1, that is 3. So it is 3G by 2. At third second. So S in third second. Again same formula. G by 2 into 2 into 3 minus 1. So 6 minus 1, 5. So it is 5G by 2. Let us continue like this, no problem. So at fourth second. S in fourth second. That is G by 2 into 4 minus 1. So 2 4 is 8 minus 1. That is 7. So answer is 7G by 2. So like this I have found out the distances in first second, second second, third second and fourth second. So 4 different cases I have taken. If you want, you could take n second, no problem, right? So if I take n second, what happens? At n second, already we got the formula. S nth is equal to G by 2 into 2n minus 1. Like this you will get, okay? So now let us find out its ratio. Observe carefully, in every case, this G by 2 is there. G by 2 is there. So we could cancel in each and every case, right? When taking the ratio, I could cancel it and I could write directly whatever that was written. So where I have write, let me write here. So distance traveled in first second is to distance traveled in second second is to distance traveled in third second is to traveled in fourth second is to so on like this. Can be written as, what is that? 1G by 2 to 3G by 2 to 5G by 2 to 7G by 2 to so on like this. Like this I will get my idea. So now G by 2 is common everywhere. So G by 2 has been cancelled. So the remaining part is 1:3:5:7. So this is what the ratio of the body traveling in each and every second. Okay? Especially for a freely falling body. The ratio of the distance covered by the freely falling body in successive intervals of time. Successive in the sense each and every second. First second, second second, third second, fourth second and so on. Okay, my dear children? So now let me write this once again. Therefore, distance traveled in first is to second is to third and so on is 1:3:5 so on. All are odd numbers. So previous case, when you are trying to find out the ratio of distance of a freely falling body for 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds like that, you are getting all are square of the natural numbers. That is 1 square is to 2 square is to 3 square is to 4 square is to, like that you got there. But in this particular concept, what you are getting is that you are not getting any squares. What you are getting is that just odd numbers. 1 is odd number, 3 is odd number, 5 is odd number, 7 is odd number. So here you are getting odd numbers, remember, okay? So in this particular case, you will get the ratio of odd numbers. In previous case, the ratio of square of all natural numbers. Like that you try to remember, okay? Have a look at this. You will understand. Very easy question.